Hello dear student, stay safe, stay home. Today we are going to start new topic, but first of all I request you again, please subscribe our channel and press the bell icon so you will get the information about new videos, and this is our effort to ensure that your learning is not spoiled. In a previous lecture we have discussed about the Mendeleev's periodic table. Who is the Mendeleev? Mendeleev is a main hero of a periodic table because they gives the main information about the periodic table. They have discovered new elements and they predicted that the new elements at that time that has not discovered. First of all, Mendeleev's periodic table. The main credit for classifying elements goes to Dmitry Ivanovich Mendeleev, a Russian chemist. Russian chemist name is very difficult. Dmitry Ivanovich Mendeleev. It is important for 1 mark because name is very difficult. Dmitry Ivanovich Mendeleev. They classified the elements and gives their basic properties. The elements were arranged on the basis of atomic mass, chemical properties, and some fundamental basic parts. Mendeleev also given the classification about the elements based on their chemical properties, their atomic mass, and another fundamental basic properties. When Mendeleev started his work, at that time 63 elements were known. Means before the starting Mendeleev's his work, before his work already 63 elements are known, and he noted that hydrogen and oxygen very reactive and form compounds with most element. You will recall that hydrogen and oxygen most reactive element of the periodic table. They gives a lot of compound with the other elements like H2O, like HOCl. You will know that. Then he gives the statement about the Mendeleev's periodic table. Mendeleev gives the statement. What is the statement? Statement is the properties of elements are the periodic function of their atomic mass. It is important for 1 mark. What is the statement of Mendeleev's periodic table? Repeat again. The properties of elements are the periodic function of their atomic mass. Means he tells that the atomic mass is a basic properties and basic fundamental properties of elements. He stated that. Then Mendeleev's periodic table. You will see the vertical column. Vertical column is called group. Total 13 to 18. Total 18 groups are present in the periodic table. And horizontal row. Horizontal means total 7 horizontal rows present in the periodic table, and it is called periods. And total group 18. Noted that. Oftenly asked as a question in your exam. Vertical column, total vertical column means group. Total 18 group present in the Mendeleev's periodic table, and horizontal row means periods. Total 7 horizontal row present in the periodic table. Now Mendeleev left some gaps for unknown elements and boldly predicted the existence of some element that had not been discovered at that time. He tells that when the Mendeleev started his work, they left some gaps for unknown elements because they are not discovered. But Mendeleev known that the gaps, the elements is present these gaps, it is the mass between the another two elements is an average. But Mendeleev named them by prefixing a Sanskrit numerical means Ika. Ika means 1. At that time the element is not discovered. They Mendeleev used for the prefix Ika means 1. For example, At that time scandium is not discovered, is unknown element for the periodic table. That time Mendeleev gives their name Ica-boron. Ica-boron means it is coming after directly to the boron, means scandium. Ica-boron. For gallium, Ica-aluminium. For germanium, Ica-silicon. It is important for 1 marks. Noted there. Oftenly used as a question. Scandium, gallium and germanium. What is the name given by the Mendeleev for the basis of Sanskrit numerical? We are written that scandium for Ica-boron, gallium for Ica-aluminium and germanium for Ica-silicon. Now some limitations, because when Mendeleev they started this work, at that times all of elements are not discovered. So some basic limitations for the given. First, no fixed position can be given to hydrogen. Hydrogen has no fixed position at that time and now, because hydrogen is similar basic properties such as similar to the halogen. You will look at here HCl, NaCl means halogen is similar properties like to alkali metal and like to halogen. Alkali metal, what is the alkali metal? Sodium, potassium, lithium, etc. It is alkali metal. And halogen, fluorine, chlorine, bromine, iodine. But hydrogen, it gives similar property both of the hydrogen means halogen and alkali metal. So they not fixed the position for hydrogen. Look at here H2O, Na2O, H2S, Na2S means chlorine, oxygen and sulfur. The compound similar to hydrogen and alkali. And second limitation is atomic masses do not increase in a regular manner. You will see that in a periodic table hydrogen is 1, helium is 2, lithium is 3, but at that time the atomic mass is not regularly increased because some of the elements are unknown. So the limitation second is atomic mass is not regularly increased. The next topic is the modern periodic table. Means when the Mendeleev started its work and they left some guess for the unknown elements, some basic error present at that time in the Mendeleev periodic table. Therefore, it is important for the modification of Mendeleev periodic table. They work taken by the hand in 1913. Henry Moseley showed that the atomic number of an element is a more fundamental property than its atomic mass. Who is this? Henry Moseley. They modified the periodic table and they discovered the modern periodic table. They suggested that the atomic number of an element, it is not important. The important is atomic number is important, but atomic mass is not important. It is noted there. And Henry Moseley is modified the statement of Mendeleev's periodic table. Mendeleev's periodic table, they concentrated and is connected with the atomic mass, but Henry Moseley is suggests the atomic mass instead of this atomic number. Look at here, Henry Moseley statement that properties of elements are a periodic function of their atomic number. It is important because in a Mendeleev statement, instead of atomic number, they are used atomic mass. But atomic number is most important. They given suggestion by the Henry Moseley. Atomic number given us the number of proton in the nucleus. This number increased by 1 in going from one element to the next. We are also known that we are calculating the element number basis of their proton, otherwise the number of electrons. Second thing is electron. So Henry Moseley given the number of elements basis of their calculate the proton and how many protons present in the element. This number is atomic number of these elements. Second is electron. The atomic number increased by 1 unit on moving from left to right because the number of valence shell electrons increase. You will know that hydrogen, second is helium. Hydrogen is one number because hydrogen has a 1 electron, so their atomic number is 1. Second is helium, 2 number. Why we are dedicated to this 2 number? Because helium has 2 electron, otherwise 2 proton. So we are dedicated to 2 number. The maximum number of electrons that can be accommodated in a cell depends on the formula 2n square. It is important for us. How many electrons present in a cell? We are using this formula 2n square. Basis of this formula we are calculate the how much electrons present in a cell. Where n is a number of given cell. For example, K cell number is 1. Basis of this formula 2n square 2, where n is equal to 1. So therefore total number of electrons present in the K cell is 2. Second is L cell. Basis of the formula 2n square, we are putting here 2. 2 into 2 square means total 8 electrons present in the second cell. Then 8, 18, 32 etc. present after this electron present is after this cell. Now most important definition, it is atomic size, and we are also known that the second name is atomic radius. Atomic size, atomic radius is similar meaning. What is the meaning of atomic size? It is a distance between the nucleus to outermost shell of an electron. Outermost shell means valence cell. A last cell, it is also called valence cell. Look at here, atomic size. Here nucleus, it is first cell and it is second cell, means it is outermost and last cell, otherwise valence cell. The distance between nucleus and outermost shell, it is also known as a atomic size, otherwise atomic radius. And some basic properties of atomic radius in a periodic table is going to left to right in a periodic table. Going to left to right, atomic size decrease. Look at here. For example, a periodic table, we are going to left to right. Left to right, atomic size decrease. Look at here, atomic size decrease. And going to upward to lower direction, atomic size increase. Look at here, in a group of the periodic table, we are going to upward direction to lower direction, atomic size is increase, because 1 electron is also added to the last, otherwise valence electron. Therefore atomic size also increase. It is important for us, so we are repeating here. Modern periodic table. Henry Moseley in 1913 is modified the Mendeleev's periodic table because they have most of the limitations. They have concentrated on the atomic number of the periodic table, and they give the one statement of the modern periodic table. Statement is properties of element are a periodic function of their atomic number. He is concentrated the atomic number of the element, and Mendeleev is concentrated on the atomic mass of the element. So this is the modification of the Henry Moseley. Atomic number is decided by the calculating the number of proton. how much proton present in the nucleus. This is the number of this element, and this number is the atomic number of these elements. And another thing is electron. Otherwise, instead of the proton, we are calculating the number of electron, how much electron present in the elements. That is the number of atomic number of this element, and it is important for 1 marks. How many electrons present in a cell? We are using this formula 2n square. Based on this formula, we are calculate the number of electrons present in the valence shell. For example, 2n square, where n is a number of cell and present in this electron. 1 square means 2, and second for 2 square is equal to 8. Atomic size, important for 1 marks. Atomic size, it is a distance between nucleus to outermost shell. Otherwise, we are calling that valence shell. Distance between nucleus and valence shell, it is called atomic size, otherwise atomic radius. Look at here, nucleus and outermost shell, atomic radius. And some basic properties of atomic size is that the going to left to right, atomic size decrease, and we are going to upper direction to lower direction. At that time, atomic size increase. Look at here, upper to lower, atomic size increase, and left to right, atomic size decrease. Most important topic of this chapter is electronic configuration of elements. Total, we are writing here total number 20 elements of electronic configuration. I am writing here because 20 is important for your exam. First of all, look at here, K cell, L cell, M cell and N cell. Total 4 cell is present. Basis of the formula of 2n square, 1 cell, total electron accommodated in the cell is 2, for L is 8, for M is 8 and N is 18. Look at here, for hydrogen number is 1, therefore it has an electron is 1. Look at here, 1. Helium is 2, here is 2. K cell is complete because in a K cell total 2 electrons are accommodated in it. Third one is lithium, 2 is complete, 1, total 3. 2, 4, 4 beryllium, 2, 3, 5 boron, 2, 4, 6 carbon, 2, 5, 7 for nitrogen, 6 plus 2, 8 oxygen, 7 plus 2, 9 fluorine, and 8 plus 2, 10 neon. Look at here, L cell, how much electron accommodated in the L cell? It is 8. Look at here, last one is 8. For K cell, total electron accommodated in the K cell is 2. Look at here, 2. Therefore, here K cell and L cell is totally filled by the electron. Therefore, we are calling the neon is a noble gas because their cell is totally filled with this electron. Look at here, 11 number. Sodium, K cell complete, L cell complete. Now we are arrange the 1 unit of electron in M cell. So look at here, 8 plus 2, 10 plus 1, 11. Magnesium, 8 plus 2, 10 plus 2, 12 magnesium. For 13 aluminium, 8 plus 2 plus 3, 13. 8 plus 2, 10 plus 4, 14 silicon. 10 plus 5 phosphorus. 10 plus 6, 16 sulfur. 10 plus 7 chlorine. 10 plus 8 argon. Look at here. This electronic configuration, argon. How many electrons arranged in this K cell? 2. How many electrons arranged in the L cell? Is 8. And how many electrons in M cell? Is 8. Means electronic configuration of argon is a noble gas configuration because total electrons are filled fully with the cell. Look at here, 2, 8, 8. Now more than one electron not arranged in this cell. Therefore, in potassium, look at here, 2, 8, 8. It is fully filled. Now next electron is added in new cell. Look at N. N cell total here 18 electron accommodated, but here is 1. 10 plus 8, 18 plus 1, 19 for K cell. Calcium 10 plus 8, 18 plus 2, total 20. So electronic configuration, you will get the screenshot of this writing because it is important for us. Many times the electronic configuration is oftenly used as a question for your exam. So you will get the screenshot of this electronic configuration of 1 to 20 elements, means hydrogen to calcium. Today, so this lecture is complete, and in this chapter Mendel's periodic table, Newland's octaves law, and this electronic configuration, some basic definitions such as atomic mass, atomic radius, valence electron, what is nucleus. This is important for exam, and we are starting the next lecture in the next day.